So, questions? Wolfgang.
Okay, if I start with your two-dimensional thinking, so it seems to me if you find one missing link, then you have to somehow rewrite history and recluster, or that there can be massive reclusterings if two clusters are quite close and there's one thing in between, and suddenly you have to regard them as one.
Yeah, well, this, like in any other clustering technique, also spectral clustering it tends to make more evident the separation between clusters, but it's not perfect in the sense that, like in this collection actually, the description of the collection, we discovered very late that it was very, very detailed. Like they have 35 different shapes of nose. So it's too much for this collection. Actually, we thought it was better if we describe 10 different types of nose, but precisely because that we use the algorithm to try with this data set, and so it's not exempt. The spectral clustering can also have that problem, but it all depends on the original description of the collection. But what it's good at is that it doesn't matter if the cluster is in any shape, it's going to find the best partition of those clusters. I don't know if I respond to your question or...
So, and if I understood it right, in the 2D part you find some things that you think are important, something like having a nose or having no nose or having a big or small nose, and then how can I say, does that somehow already include the result that you will go that you are going to find, the list of criteria that you have, and if I understood it right, then they are somehow you have no nose, big nose, small nose. Also, then you have so you have discrete values for nosiness, and does this turn out to be a good way of describing similarities, especially because in the second part you seem to have a completely different approach of trying to take more like continuous data from your 3D things and trying to do it without any information from you know what I mean.
No, yeah, exactly. That's a good point, because the first part, the clustering that I presented, is actually the traditional way we work in archaeology. We define some attributes that seem relevant to our collection or to our research. In this case, we're 23 attributes. So that's the traditional way. But we want to go beyond that. That's like our challenge, is to go and probably do the classification without the need to, for the machine to view the attributes, right? Let's say that the machine view the attributes mathematically, like a mathematical description of the shape attributes. And that's what we are intending to do in the second 3D part. So that's what it's a separation between the traditional way, which is the clustering. That's what we started, but now we are moving from that to do it automatically, and that's the experiment. Let's say we haven't succeeded completely because we are only at the stage where we can recognize shape globally. So next year is going to be a big let's say test for us, because we will start using partial matching to see if we managed to do that. In fact, we have implemented a software for classification in 3D with these descriptors, but it's not really working because it's only global. So it's not point to show it, because we know it's not working as it should. So that's but it's a good point. It is totally separation between the traditional way that we work, which is still good. I think it leads to good results, but we are trying to experiment with techniques with more automatic recognition techniques. Mm-hmm.
But you still want to find with your 3D approach still the things like having something on the back or a specific kind of nose that you showed in your 3D thing.
Mm-hmm.
Do you still try to emulate the classical way?
Oh yes, mm-hmm. Yes. I would say, yeah, it is. One way is that I want to isolate that feature, like this kind of nose with the like has this how you call it, like intertwined nose. This. That's one thing to see. Or the other one, if it is fully automated, I will say only these two objects are similar, but because they have many more features. Probably not only the nose, but maybe the kind of this. How do you say in English? What you call the pot? This, well, yeah. But yeah, we're still seeing the problem as in a traditional way. Yeah, that's a good observation. Yeah.
Yeah, that's good.
Did you try to find, or did you test to find the same object, probably in different kinds of photographs or slightly different ways of reproducing them, representing them in 3D? So to say, you now you are searching in a group of objects of which you know they are all different,
Mm-hmm.
and you try to put up clusters of not so different things together.
Mm-hmm.
Another interesting test case would be, at least with 2D, to run tests through a big bulk of material where the same object is represented in slightly different
Mm-hmm.
ways.
Mm-hmm.
In Oxford, they were able to detect certain objects in the 1.5 million scans of Arachne, and saying you have them 4 times. That must be a mistake. It wasn't a mistake because they were represented in 4 different, kinds of object groups. It was always the same thing, attributed to different data sets, but they were able to cut them out on different photographs, probably understanding that it's still the same object, even if the lighting and things are slightly changing. And also Google search does this. If you play with it, you can get a lot of results and a lot of noise, but on the top are always quite nicely grouped things which are the same object if there is, if it matches to
The criteria.
an object, and so that's a good testing case also, I guess, not only to cluster similarities, but find out identities in not so identical representations of always the same thing.
Yeah, I think for that partial matching would be good. Partial matching meaning not only that details.
Yeah.
That's one of the things that partial matching does. But what partial matching does is say they have 20 partial matchings each object against, and these other only have 1 or no or 0. So partial matching is not only that I will be able to find a detail in the artifact. It's not focusing on nose or eyes, but to see how much of these details, how much parts the object is similar to the other one. Like this artifact is one of those, has that problem. Let's see, this is only one example of a group of male deities, but they all are in this position. It's all pretty much a standard way to represent a deity in the Aztec times for certain kind of deities, like the deities linked to the fire and war, but they all change in the type of headdress and everything. So the partial matching will allow us to find all of them, or the global matching find all of them, but to say, well, these are 2 identicals because they have all the details also similar. Or these are not identicals but are pretty much the same because they are all in the same position. So that's the problem. That's the thing with this artifact. When it finds not only what we are finding here is not only there are two identicals, and the other three that finds the algorithm are not that identicals, but are pretty much the same kind of configuration. So it's
Just
I have a couple of points that I would like to ask you about. First, goes a little bit on the line of what Volkan was saying. If you can explain a little more about what kind of description for each item did you input in the Classicist input? If you picked some traditional description of the masks and you grouped, you used a group of features that were already established by archaeologists. The second point is if you evaluated the result of your clustering with some grouping or some studying that was done very traditionally by other archaeologists, to compare the groups that were found by your methods with studies.
Yeah, but actually the comparison is the previous clustering. Let me see what is this one. This is, well, we use the same data set to compare exactly. So they define different types of noses, different types of eyebrows. So typical work like we do in archaeology, like this, right? The kind of eyebrows, the type of nose, and the result, that work resulted in this clustering, the one I show, this one. Those are the results with total linkage numerical taxonomy. And what we found is the other one, this one. So yeah, we have compared, and actually we reduced the number of groups to 25 versus 40 plus 20 objects, which are single objects, right? So we think we improved the clustering. Probably we can even improve it more if we use another data set. Like as I said, the collection is over-described. That means there are too many types of noses, too many types of eyes, eyebrows. So we reduce that to more basic types. Then we will find a better algorithm, I think. We will find better clustering. So we were not really much about solving the problem with this particular collection, but we wanted the methodology. But now that we have done it, then we are going to do that, to publish also the clustering as from an archaeological point of view. Aztec archaeologists will be interested to see a better clustering, right? Because we have now a good one, but I think we can still improve it if we reduce the number of descriptors in the code, in the dictionary. Yeah, and so yeah. So as you see before, this is different. You see this has different details here and here. So these two are different than the one. So we're still finding that thing.
I was just going to ask where you actually get your 3D objects.
We scan it ourselves. Yeah,
okay.
we do the modeling.
Because then, if you actually have the collection in one place and you scan them all yourself, then the problem of identical objects should not come up, because you can see all of them.
Oh yeah.
So in this particular collection, the problem of identical objects should not appear.
No, it's not that the problem is something to be solved. That would be a test case for me in the end.
Okay.
I meant that as a test case.
Yeah, as a challenge.
And as a challenge, as long as you believe that there will be 3D model collections in the future, in a way on similar technical basis that makes them retrievable or searchable, then this would come up. Even I would say, a system that can resolve this is able to resolve the rest too. So that was the meaning of my questions. Otherwise, as long as digital collections of 3D models are so small as they are, you won't have the same problems as with image collections, which are probably even separated and displaced over the web and get together and get searched together like Google search. That's another thing.
Yeah, but also the next thing for us is probably to try to scan collections in other museums that belong to this type of objects. There is about 1,500 masks around the world from the same kind of masks, in Los Angeles, in Vienna, in Berlin, I think in New York. In New York they have 400 in the National History Museum. So we are trying to find permissions to scan those objects, because then we will have the collection more or less complete. It's not impossible to do it because it's not thousands, it's probably 1,500 at the most. And we scan 500 objects in about 7 months, 8 months, so it wouldn't be that big a problem. The problem with 3D modeling is probably in archaeology is that the scanners so far are not very good reproducing the textures, like the colors, real colors. There's a lot of problems with that, and in all conferences I have been, nobody knows how to solve it, except with a special scanner that they produce in Canada, and it's one in London. So they can do perfect coloring and texturing, because instead of having one laser reading the shape and a digital photograph, what this new scanner has is 4 lasers, one for each color and one for the measurements. So it's not actually taking any picture, but measuring the reflection of the light and taking the real value of reflection, so producing the colors perfectly. But it's only 5 scanners in the world, one in London. But other than that, that's a problem with 3D modeling. That's what we are showing this in this appearance without much color, because it's really not very good.
I have 2 questions myself. For the first approach you showed, is there a possibility to weigh the relevance of the attributes? Or are they all treated equally? So do you have any chance to form the clustering, like saying the nose is more relevant than different information, or are they all treated as equal categories?
Right now we are treating them equal, but you could actually just multiply the importance, the weight of the similarity function for that particular attribute, because it's measuring the similarity for each attribute. So you could actually put a weight on that, but we didn't want to do it because one of the things we want to learn about this collection is what's important to describe this collection: the eyes, the eyebrows, the mouth. And I learned in the last weeks actually that the best clusterings are, I got the best clusterings considering the eyebrows and the nose. And not so much the eyes did not matter much. Although we tend to focus a lot on eyes, the shape of eyes, but it's more the eyebrows and the mouth that define better groupings. Obviously the general shape of the mask. But the attributes that we were considering is 23. I actually eliminated for the final clustering 4 of those attributes which are not relevant. Decoration was not relevant, actually was inputting some noise in the data. So yeah, you could learn by trial and error. But right now we treated them equally.
And the second question is, do you plan to enhance the 3D approach you just showed, and with more information which is not based on the sole geometry information, but also other information like material or color, which could influence the clustering as well. So this approach you showed tends to concentrate on the geometry and the formal aspects of the object.
In the 3D.
Yes, in the
Yeah.
3D approach. But leaving out other information like, yes, size of material or of colorings, which could influence the clustering as well. So do you tend or plan to combine that somehow? So to have some sort of categorized information and the geometric information?
In the case of the 3D, no, because we want the technique to be totally blind to any of those details, which is bad in a way because we discard known information, but it's good in a way because we want it to be generic. So, in the 3D case, we are not considering. In the 2D case, we must to get a better clustering because so far in those 23 attributes, it's not single attribute linked to the manufacture technique or the material, which for at least 5 years ago, someone discovered that is very important. And we found it ourselves by clustering, or the material is the same, the stone is the same, the clusters. I said, well, this is important, right? We didn't know. When you see the 162 mass there, we didn't think about it. So we know. And just now, this is someone doing microscopic analysis of the manufacture techniques, the manufacture marks on the objects. So we will probably, if he is willing to, we'll share his information. We are trying to convince him to join the project, to share the information with us, and then we will have a more. But in that sense, it's a lot of discussion, particularly for this collection, because there is two theories. One is the Aztecs used the masks. They were produced 1,000 years before the Aztecs, or hundreds of years before the Aztecs, and they collected these artifacts and put it in the offerings as relics, or for some religious reasons, just put it in their offerings. And the other theory is that no, actually, probably some of these styles survived, or the Aztecs themselves manufactured copies of the artifacts. So it's a big discussion, academic discussion between that. I personally believe these are antiques collected by the Aztecs and deposited in the offerings. It's more reasonable, but because the manufacture techniques are showing that they have some marks that only in Aztecs time appear. There is the guy who's doing this work said, no, I found that these are actually are copies. No, these are copies made by the Aztecs. But that doesn't prove anything because the mask could be, the Aztec could have polished the old mask and decorated the old mask. So it's a lot about this collection that has academic implications. So, yeah.
Just one other question. You said that in the future you want to have the computer guess the number of groups. So can you say in very general terms what your approach is to this?
It's another mathematical technique to actually try to find how the eigenvectors separate one from the other. It rotates the eigenvectors. What it does is a coordinate system. So you have 10 eigenvectors for 10 clusterings. It's a coordinate system of 10 dimensions. And what it does, this technique does, is to rotate this coordinate system and try to see how the original data, arranged according to the rotations, and try to see where are more likely to find good cuttings of the graph. So, yeah, so that's what we are trying to accomplish next year. Yeah.
What is the learning part about that?
Sorry?
What is the learning part about that?
The learning?
You said the system tries to learn the number of
that can identify how many cuttings could be, or how many subgraphs are possible in the general graph. Once it's a graph, then it tries to learn how many subgraphs can identify, and that's, like say, it's learning how many subgraphs instead of imposing. When you, as we have it now, you say, I want 10 clusters. With the K parameter defines 10 clusters. So you don't learn nada, you impose in 10 clusters. You want 10 clusters and the machine finds 10 clusters. In the other approach, that the technique that we are trying to experiment with now, is that the machine indicates, well, maybe are 11 or 9 clusters, and suggests a partition. So it's that's more, let's say, it's learning from the data. Mm-hmm.
In your 3D situation, following up on Felix's question about color, also, can you rule out, on the contrary, that you that the result is affected by things that you are not interested in, such as the preservation status of the objects?
Like you mean, if we have a bias, imposing the bias? Yeah, I think we do always.
Can you somehow guarantee that your algorithms will cluster the objects according to criteria that actually humans will find interesting?
You mean in the case of the 3D or
in the 3D?
3D. Yeah, we believe it does, because finally we are working with shapes. So, but like ontologically, it's difficult to say, because maybe the machine sees, even with some experiments that we do, sometimes maybe the machine is seeing that this object is similar to this one, whereas we have some semantic information telling us that this is different than this one. Although in this mathematical or geometrical criteria that the machine is using, it's the same or similar. Mm-hmm. So yeah, we are not introducing semantic information, and therefore we are imposing a bias. So we are losing something because we don't have any semantics involved in the geometry, and yeah, that's a limitation, a weakness. Mm-hmm.
Just to expand a bit more on this point, I don't grasp the whole thing of the mathematical foundation, which is quite complex, but I think this clustering technique is quite similar to what topic modeling is to test. So the number of topics is defined by the user, and then you get some possible hypotheses about how the topics, the clusters of topics are composed. And I think this is quite similar to that. But still, you need the user to evaluate if a topic of text makes sense, if a group of text makes sense or not. So my question is, did you evaluate the results of the clusters with some domain experts saying these clusters of mass make sense to me or not? And
yes,
can you expand a bit more?
Yes, we did. In the case of the clustering, yes, definitely. And we found that people identified saying this is Chontal type recognized, or this is Teotihuacan style, and this is I don't know, Mezcala style. There are the three major styles for this collection. Yeah, we did with the different clusters. Yeah, and that's what that's the criteria we used to say, well, yeah, it was a good clustering. We succeeded in that sense. Let me see if I have the presentation.
But the important point is that it's still an
like
exploratory technique, as you said.
Yeah, it is exploratory. Like this is called the Chontal style. Like this is known as a Chontal style, which have these perforated eyes, this kind of eyebrows. When the experts saw it, they say, "Oh, that's Chontal," right? So this is called Sachila style. This is another style, very highly polished stones with very big nose and very flat, and this kind of green stones, which are not included in the algorithm. So it's clustering the shape, but obviously the shape also in this particular case is also linked to the raw material and the technique, right? That these are not considered as attributes in our algorithms. So it's another test that it was good. And this is a typical Mezcala mask, no? So yeah, and this is another Chontal, but with you see the separation of the eyebrows. and sometimes so we have some the cheeks. So yeah, it's in that
So
sense.
in this case, you have a confirmation
Yeah.
that the algorithm is able to define, to identify.
And in this was a big
clusters of small
surprise.
size.
Because there were some masks that people didn't know where to put them together, and that's when one expert said, "Oh, but these are Teotihuacan style. Maybe not original, but maybe these are copies. Probably these are the only ones in the collection which the Aztecs copy from Aztec times. So probably." But these are more likely to be Teotihuacan style, which has nothing to do with Guerrero state, but with other area in Mexico. So yeah, we had this confirmation.
Yeah, the point I've always tried to think of how this would play with Greek statues or heads from Roman times. And first question would be, would that be possible? Is that your software, or do you give it away for testing to others?
Yeah, sure.
Could we do it? Could
Yeah,
you give
sure.
it to us and we play with it?
Yeah, definitely.
Second question would be, if that is possible, what really would be a great joy and a great jump for us. On an ontological basis, one could say there is no right clustering or wrong clustering. There are conceptions, human conceptions of right clusterings, and interesting parallel discussions about what is important here. So the specific German part of art history that is being called archaeology in Germany invented style as a sort of human visual observation about the way in which specific motives are realized in a specific object. You can realize an ear, you can say you have an ear, but the way you realize it says a lot in our conception about if this is a Greek ear, an archaic ear from 600 before Christ, or a classical ear from 450 and so on. Yeah, that's funny, but in a way we have the feeling it works. And art history in later periods is working more or less the same way. There are periods where it's difficult or practically impossible, and there are periods where it works. So we are trying to do this, and I think in a very, very virtual way. Nobody sees the same thing like the other. And nobody feels about it the same way. And each description of an archaeologist, of a clustering, and of his criteria, and about the rightness or the wrongnesses of the clustering of other concurrent archaeologists, are in a way also virtual discussions. And if the eye, for example, the eye is a holy property for style research in classical archaeology, because they say the eye is so sensitive for any kind of change. So just look at the eye first, and you see the change. And that works too in some periods, and in others it don't. So I think if you take the whole methodology of what you do to, in a way, also measure what we find, and probably why we find something similar or not. If you have this kind of machine, this kind of intelligent machine, or at least a machine that can learn or that can teach something, and say you change the properties and the similarities and the algorithms, as long as you can automatically reproduce a clustering that has been done by Walter Herwig Schuchart in the 1920s of a specific group of 20 chorai from the Acropolis, then you would have catched, the reception mode of Schuchart, the visual reception mode. And that would be interesting, because it's kind of, don't know the English word, kind of close to Wahrnehmungspsychologie or so, in which every archaeologist or art historian uses as a filter, and it has never been described or in a way nailed down to what it is. they learn the job, and then they see, you know, who doesn't see this is dumb or just wrong. Look at this and look at this, and so we have a lot of also fruitless discussions about what is similar and what is not. So in classical archaeology, where we don't have a document that documents each, let's say, copy of a portrait of the Emperor Augustus, we are stuck and bound to style. And we are doing this kind of ritual clustering ourselves, and say what we find interesting is our problem. What the algorithms are finding interesting is another problem. And who says that we are the measure for that? Naturally, there are cases where it is clear, because objective data from the outside are there to say that belongs together or that belongs in no way together. Then you would always still have to find an answer why things that cannot belong together look so similar, which is also more often the case than people like to think about in stylistic discussions. So I think that could be a good tool, and in a longer perspective one could even try, you know, to in a way analyze the way our ancestors or ourselves we are looking at things. More interesting to learn about the way how we do visual clustering than just saying we are the measurement for this algorithm to work. So I think this is a real great area of research which can, if it opens up, really change many things in visually oriented research.
Well, hopefully.
No, really, if you look at it the right way, it's not to say, you know, for a museum or for a keeper of a photographic archive to say, can this thing do the stuff for me, and I look at it and I find it right and the job is solved, which is a very short-sighted which is very practical, and I would love to have this, but it's only a short-sighted aspect of the whole thing.
Yes.
If there are some broken parts, isn't there any possibility that it causes mistakes? For example, if the nose is broken by a part, by some masks, it might be cause mistakes. I could imagine.
Yeah, in fact there are some damaged masks, but because the other attributes are very well coded, there were not so much of a trouble for that. And the other thing with this collection is only 3 or 4 fragments, which are maybe half the face. Just so I think we show here these ones, right? So we don't have much of a trouble for this particular collection, but obviously in another kind of collection that would be a problem. Yeah.
Any further questions for public viewing? No, not so far. So I think we can gratefully thank you once again.
Thank you for being here.
Switch to the liquid part of the evening, to the wine and the water, and yes, wish you many good progress with the further questions.
Thank you very much.
Algorithms you still planning to implement, and
well, thank you very much.
Good luck for that.